we now, in a similar pattern to the other questions that have come up in previous years, we add another resistor in parallel with the second part. First of all, we ask to calculate the total resistance of that altered circuit. Alright, so when we're doing this, we need to first of all work out the resistance of this parallel part of the network, followed by the resistance of that 4 ohms in series. So we say for the parallel part, so the resistance of the parallel network is equal to, it's 4 and 2 in parallel, so it's going to be the product over the sum, so that's 2 times 4 over 2 plus 4, which is equal to 8 over 6, so that's equal to 1 1/3. So we have 1 1/3 here for the parallel part, plus 4, so then the R total is going to be equal to 4 plus 1 1/3, which is equal to 5 1/3 ohms. So the total resistance is 5 1/3 ohms. The next part of the question then asks us to calculate the new reading on the voltmeter. Worth looking at the circuit diagram there again for that. Okay. We now have 4 ohms and 5 1/3. We need to know what the current is through here. If I want to know the voltage reading on this, I need to know what the current in here, so I can use V equals IR. So we're going to work out first of all the total current. Okay, so I is going to be equal to V divided by R, and in this case V is equal to 12, and we're dividing that by 5 1/3. So that means that the current that flows around there is equal to 2.25, 2¼ amps. Then we can work out across the 4 ohms, so we're just going now, that means 2.5 amps, or sorry, 2.25 amps comes out from here. That 2.25 amp goes through there, and then it splits up, some goes there and some goes here. We're just looking at this voltmeter here, so it's a 4 ohm resistor, so we can say V equals IR. Therefore V is equal to 2.25 times 4, which is equal to 9. So we now have 9 volts across there. Okay, so we get a new voltmeter reading of 9 volts.